Hello everyone, so today's topic is going to be the P-series and ratio tests. I've decided to move this video about a day forward just because P-series and ratio tests kind of had to be done separately and I had to combine them, which took a little bit, and it's also just a bit better to watch these separately. So one day could be P-series, one day it could be ratio tests, but nonetheless in the same video. So P-series and ratio tests are very simple concepts to learn, hence why I have combined them in the first place. So first let's talk about the P-series test. The P-series test is very, very simple. And all it states is that if I have a sum, n equals whatever, 0, to infinity, or really any value, 1 over n to the p, if n is greater than 1, so if n is value 2, 1.5, 3, 4, 5, so long as n is greater than 1, and p is also greater than 1, then this will converge. If p is not greater than 1, then you can conclude that it most likely diverges, but then again, that's not part of the test. So the P-series test is really a test of convergence, because if p is greater than 1, something will converge. And as a matter of fact, if you Google any of these tests, you can find literal images on Google that tell you the exact parameters for this test. You'll find this image, and it says if p is greater than 1, then this will converge. And why is that important? The importance of that is that this is an open note test. So what you can do is look up every single test for convergence, divergence, etc. The ratio test, the Leibniz test, the limit comparison test. So there's a variety of different tests, and you can just look them up, and then once you look them up, you can just save them to a document and use that document on the test, print it, and use those notes on your test. And that's completely fine. That's totally acceptable. That's something you could never do before. So I would highly recommend just saving notes of every single one of those tests, as opposed to, doing something outlandish and just trying to memorize them all. You don't need to do that anymore. So we have this. So in other words, if I give you a quick quiz, hey, we have 1/2. 1/2 to the power of 3. I should use n. Sorry. Actually, n can't start at 0. N has to start at 1. Ha 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 ha. And then, let's say n increases by a factor of just p. P is 3 because 3 is greater than 1. Yeah, you should be good. Now, I said earlier that n also needed to be greater than 1. And this is true so long as n is this value is constantly decreasing. So if this were this would not work, because the value of this what's in the parentheses is constantly increasing. So you have to have a fraction, because this will be 1, then 2, then 3, then 4, as opposed to, if it's 1 over n, it's going to be 1, then 1/2, then 1/4, then 1/8, then 1/6, then 1/2, then 1/3, then 1/4, then 1/5, then 1/6, and so on and so forth. And this power will affect it to the point that it gets smaller, because a fraction multiplied by a fraction is smaller, because 1/2 of 1/2 is 1/4, that's smaller. So if this is 2 and this is 2, then there you go, you have a smaller number than what's in here. So that works. When you put a fraction to a power, it'll get smaller. All right, so that's the ratio test. Not ratio test. That is the P-series test. P-series test is testing for convergence if p is greater than 1. Now let's talk about the limit comparison. The ratio test. Sorry, not the limit comparison test, but it's very similar. All right, so what this is saying is, we actually did this yesterday. This is trying to find this is literally the same thing as finding the radius of convergence. You just have to find the radius of convergence. This seems very familiar. So you take a term in a series, and then you have the next term in the series divided by the last term in the series. And it's very simple. It's very, very, very simple, because it's just finding the radius of convergence. And what this says is, if you get a value, if the radius of convergence is decreasing, in other words, if it decreases by less each time, if this is less than 1, then that means it converges for sure. Now, if it is greater than 1, then it is divergent. That means the series diverges. And if something is equal to 1, then it's inconclusive. So just to summarize, if it's less than 1, it's absolutely convergent. If it's 1, it's inconclusive. And if it's greater than 1, then it's divergent. All right. The difference between absolutely and conditionally convergent is complicated, and we might go over that later If anyone needs help, just let me know. All right, so a of n and a of n plus 1. Okay, cool. So let's do something like, I can't come up with any solid examples, but realistically, let's do something like 1 over 3 plus n or something, you know, something simple like that. Cool. All right, well, if we do the next term in the series, well, the next term in the series is, or let's do, you know, e of n up here. There we go. Cool, that makes it nice and complicated. So e to the n plus 1 over 3 plus n plus 1, so that's 4 plus 1, 4 plus n, divided by, or multiplied by the inverse, right? Because it's fraction, 3 plus n, 3 plus n, e to the n. This is e to the n times e. These cancel out, you get an e, and these more or less will cancel out because these are more or less n. These are more or less cancel out. So you have e to the n at infinity, sorry. So this is a limit, again, at infinity, because when n is infinity, 3 plus infinity and 4 plus infinity are both infinity, if that makes sense. All right, the e to the n's cancel out, and you end up with e. So that means that your limit, as n approaches infinity, is e. And e, in case you guys don't remember, is about 2.7. And 2.7 is not less than 1, which means that this is divergent. Cool. So that's just an example. I'm not going to go over examples that are equal to 1 or less than 1. You guys kind of get the gist of it, and I hope that you enjoy the rest of your day. Hopefully, we're getting near the end of these videos, but I hope you are well prepared for the AP exam if you do watch these videos. All right?